What do a helium-wrapped Rocky world, a lonesome spacecraft with 68 kilobytes of memory, and black holes shedding mass in spin-dependent ways have in common? They all landed on our desk this week, and they're all quietly wonderful. You're listening to Science Week, Episode 2, The Science of the Week for July 22. I'm Grace, and with me is Daniel. Let's get curious.
I like that we're starting with a question. It sets the bar high for evidence and low for hype. We have a clean set of results this week. Astronomy heavy with a strong dose of brain and planet.
And a through line of boundaries. What separates inside from outside? A blood-brain barrier, a marine protected area, an atmosphere clinging to a world, a spacecraft beyond the sun's bubble, and black holes testing the edge of physics. It's a poetic kind of week.
It is, but we'll keep our feet on the ground. For each study, we'll say what's actually shown, what's still inference, and what comes next.
Perfect. We'll start with life and the brain, then work through health and the planet, and spend some serious time in space before peeking at the deepest physics. And yes, we'll end with what all of this adds up to.
Also, a quick reminder, this is a weekly look back. If it sounds too tidy for a breakthrough, that's on purpose. The science is what it is.
Spoken like a true methodologist. Let's go. In the brain this week, a team led out of Cleveland reports a link between a protein called KLF4 and the integrity of the blood-brain barrier, and they connect that to cognitive loss. The work was reported by SciTech Daily and published in the Proceedings of the National Academy of Sciences.
Here's what that means, cautiously. The blood-brain barrier is the cellular filter that protects brain tissue from things in the blood that shouldn't get in. The report identifies KLF4 as a regulator of that barrier's integrity. They also link changes at that barrier to cognitive decline.
Why it matters is pretty intuitive. If the barrier weakens, the brain's home turf gets noisy and inflamed. People hear cognitive loss and think of aging, injury, or disease. And the idea of stabilizing that protective wall is compelling.
A few guardrails. The report links KLF4 to barrier decline and to cognitive effects. It doesn't, as far as we have here, establish a clinical therapy or show reversal in patients. The summary we have doesn't list sample sizes, species, or duration, so we should treat it as foundational biology rather than a medical intervention.
So it's a mechanistic clue, a named protein that seems to be one of the dials on the barrier's strength.
Exactly. The next steps, to be rigorous, would be replication, quantifying effect sizes, and testing whether modifying KLF4 meaningfully preserves barrier integrity and cognition in controlled settings. From there, safety and translation become the long road.
Still, naming a dial is progress. It gives researchers a handle, and maybe one day, people a little more resilience upstairs. From an internal barrier to an external one. The BBC reported that the former prison island of Euros has been designated a protected marine area. The island once held political prisoners and was even used for naval bombing. Now, it has the highest level of environmental protection, and conservation officials say it hosts a significant colony of endangered seals and seabirds.
This is policy, not lab science, but the logic is very empirical. Protection status correlates with better outcomes for vulnerable species, when it's enforced well. Here, the point is to give endangered marine life quieter waters and safer shores.
I love the symbolism. An island once reserved for punishment and explosions, turning into a refuge. A line on the map can be a life raft for biodiversity.
Caution still applies. Designation is a legal move. Real conservation outcomes depend on monitoring, resources, and compliance. The report notes the highest level of protection, which is promising, but the work of recovery is years long.
Fair. But sometimes the big step is the first one. You pick a place, you draw a boundary, and you say, this counts. Then you do the hard, patient science of counting birds and seals season after season.
And you use those counts to adjust what's working. It's the same humility we ask of medicine. Measure, revise, repeat.
From seawalls to sky vaults. Let's head outward. A team of astronomers reported a helium-rich atmosphere around the Rocky Exoplanet LHS 1140b. It's Earth-sized, in the habitable zone of a red dwarf, and only about 48 light-years away. The detection came from spectroscopic observations. The light passing through the planet's air showed absorption features that match helium signatures.
Let's parse that. Helium-rich here means the data match helium's fingerprint in the spectrum. It's a sign that the planet has an atmosphere that includes helium, and possibly in notable abundance.
Which is a lovely thought, a rocky world with a faintly alien, helium-tinged sky.
2 cautionary notes. First, in the habitable zone describes starlight and distance, not actual habitability. It doesn't tell us about surface conditions, liquids, or life. Second, spectral detections can be subtle. The team is reporting a match to helium features. As with all such claims, independent confirmation will matter.
Still, it's a big deal to see an atmosphere at all on a rocky planet. Gas giants wear their atmospheres like neon signs. Rocky worlds are stingier. Finding one with a clear helium signal suggests we're getting better at reading these faint cues.
And the technique is the story as much as the target. Spectroscopy lets us infer gases from the way they absorb starlight. It's indirect, but powerful when the signal is clean.
This is why space feels less like science fiction and more like weather reporting these days. Skies on LHS 1140b? Helium likely.
With the disclaimer that the forecast is based on one set of instruments and one analysis. More to come.
Staying in the sky, but a little closer to home, within our galaxy. University of Utah astronomers, including Matthew Whitaker and Anil Seth, identified the first stellar mass black hole in the globular cluster Omega Centauri. They did it by analyzing more than 20 years of Hubble Space Telescope observations and incorporating recent imaging. That's according to KSL News.
A few definitions. Stellar mass black holes are the remnants of massive stars, as opposed to the supermassive ones at galaxy centers. Omega Centauri is a dense, old cluster of stars. Finding a stellar mass black hole in a cluster like this is significant because it speaks to how these environments evolve and what kinds of remnants they retain.
And the method, 2 decades of Hubble data, is a reminder that astronomy is a waiting game. You let the universe draw you a line by moving ever so slightly, and then you trace it.
Exactly. But we should be precise about claims. The report identifies the first stellar mass black hole in that specific cluster. It does not claim a full census. One detection implies there may be more, but that's a hypothesis, not a result.
It sets the table for follow-up. If there's one, maybe there's a family. And either way, it adds a dot to the map of where these objects live.
The validation step is also important, making sure the signal isn't from something more mundane. Using long baseline imaging helps, and incorporating newer images suggests they've cross-checked.
I like that Hubble, after all these years, is still the quiet partner in so many new stories. Speaking of long service, NASA confirmed that Voyager 1 is still operating in interstellar space. It's cruising at about 38,000 miles per hour, roughly 1 light day from Earth. It has no active propulsion, it's coasting on gravity assists from the 1970s, and it's doing all this with about 68 kilobytes of memory. Space Daily carried the report.
The numbers matter here because they put scale on the table. 1 light day is an intuitive way to grasp distance. It's still in our cosmic neighborhood, but well outside the planetary family. And 38,000 miles per hour sustained, without engines, is a clean lesson in orbital mechanics and momentum.
And the memory, 68 kilobytes. That's a charmingly small figure, yet it keeps sending back data from beyond the sun's influence. There's a kind of engineering humility in that.
It also underscores how careful NASA has to be with commands and diagnostics. With limited resources, every instruction is a trade-off. The confirmation that it's operating is itself news because it means the communications loop remains intact.
I picture it as the steadfast elder of the fleet. No fuss, just the cosine of a trajectory and a radio whisper.
Poetic, but accurate in spirit. It reminds us that well-designed systems can outlast our expectations by decades.
Now to the deepest physics on our list. Researchers reported that Hawking radiation and mass loss rates of covariant quantum black holes vary with the spin of the emitted particles. The analysis shows that higher spin particles lead to faster mass loss compared to lower spin ones. This was reported citing a ScienceCast article.
This is theory territory, not direct observation. Hawking radiation is the predicted quantum process by which black holes lose mass. Particles are emitted near the event horizon due to quantum effects. What's new in this analysis is the explicit dependence on the spin of the emitted particles, with spin meaning an intrinsic quantum property.
So if a black hole's quantum leakage favors higher spin particles, it sheds mass faster than if it favors lower spin ones. That's a striking tweak to the mental picture.
It is, but we need to set expectations. No experiment here is directly measuring black hole evaporation. The effect is far too faint for astrophysical black holes with current instruments. This is a modeling and analysis result, valuable for sharpening the theory, but pending broader scrutiny and consensus.
Still, it's exactly the kind of refinement that brings two grand frameworks, gravity and quantum mechanics, into slightly closer conversation. Even the phrase covariant quantum black holes sounds like a bridge builder.
Right. Covariant here signals that the formulation respects the symmetries of spacetime, which is crucial for consistent physics. The claim, as reported, is specific. Mass loss rates vary with particle spin, and higher spin accelerates evaporation. It's a clean hypothesis against which future theoretical work can test limits.
And maybe one day, if we can't hear it from a black hole, we'll learn the lesson in an analog system, like laboratory setups that mimic some horizon behaviors. Not a promise, just a hope.
A reasonable one. For now, the takeaway is conceptual. Particle properties matter to the evaporation ledger.
Let's stitch a thread through all of this. The week's stories are about edges and what crosses them. The blood-brain barrier decides what may enter the brain. A protected marine area draws a line around life and says, not here, not now. An exoplanet's helium signature is an atmosphere holding on. A spacecraft slips across the sun's boundary and keeps going. And at a black hole's event horizon, theory tells us the properties of particles decide how quickly mass leaks away.
Boundaries are not just walls, they're testing grounds. In medicine, we test whether a molecular regulator like KLF4 is a meaningful dial. In conservation, we test whether a protection line changes outcomes. In astronomy, we test whether spectral lines are robust signatures. In physics, we test whether a model survives peer challenge.
And the older stories, Hubble's archive, Voyager's cruise, remind us that science rewards patience. 20 years of images to spot a compact mass in a star cluster. Decades of silent flight to reach interstellar space. You can't rush certain truths.
Nor should you. The theme I'd keep is measurement. Each result this week comes from careful measurements of light, of motion, of proteins, of policy impacts, paired with restraint in interpretation.
Which, to me, makes the wonder feel earned. When you know the edges of the claim, the center feels more solid.
That's the goal.
That's our tour for this week. If you want calm, checked news without the noise, come by faxlane.com or grab the app on the App Store or Google Play. It's our daily companion to this weekly show.
And if you like your weeks well-rounded, we also make Good Week and Tech Week. Clean, informative takes on the world and the tools we're building.
Thanks for spending time with us. Keep an eye on the skies, spare a thought for the seals, and take care of your own internal boundaries.
Measure twice, claim once.
Stay curious, and we'll see you next week.